Good morning, everybody. I thought it was not working. Thanks for joining my talk. It's great to be back here in Barcelona. And today I'm going to share my lessons learned with our Kafka journey at ING. First of all, I'm Tim van Baarsen. I'm a software developer in the Netherlands in ING, based in Amsterdam, and I'm in the Dora team. And of course, that's a big wink to the writer Franz Kafka, who sent a lot of messages to his fiancée Dora. We're with a quite big team because we're serving a lot of teams in ING. So half of the team is in the Netherlands and half of the team is in Romania. We're active in more than 40 countries, and Kafka is used quite a lot within ING. So I think I can say we are front runners in Kafka. We are running Kafka in production for over 7 years now. We have more than 5,000 topics in production. We have several different clusters for several use cases. And we are serving more than 800 development teams within ING. Some of them probably don't even know they're using Kafka, because we're using Kafka as well for shipping logs to Elasticsearch. We're shipping metrics for a lot of applications. But yeah, a lot of teams also using Kafka for publish, subscribe, and of course a lot of real-time Kafka Streams use cases. Next to that, we're also offering them a Streams marketplace, so they can create topics, they can give other teams access to topics. So that's what we're supporting as well, to have full control over the topics, and we also know what topics are created by which teams to do some governance on that as well. So it's an exciting place to be. Kafka is quite big in ING and became basically a nervous system for ING. When we started back in 2015, we only produced some data to Kafka, and it grew quite steep. So on average, we are receiving from all kinds of teams around 500,000 messages a second. This is on average, right? So during the night it goes a bit down, and during office hours way more. And the traffic is growing basically 10% a month. So it's a steep curve, and it also brings some challenges to keep everything stable and keep everybody happy. But it's awesome. The agenda for today. First, for people who don't know Kafka, I will give a quick introduction to Kafka, and then we're going to Spring Kafka, and I would like to show you some scenarios with live demos. We're going to break stuff, we're going to fix it, and we're going to use Spring Kafka for that. So I would like to run an example, a scenario where we have a poison pill. We're going to see deserialization exceptions. We see this quite often with teams. They get this exception and they don't know how to handle it, so we will go into that. Also, another example of lack of exception handling. We take a look at a bit of testing, monitoring as well, and then we're going to wrap up. And let's see if we have time for some questions as well. So without further ado, Kafka in a nutshell. Of course, we need to have a broker, right, to store some data. In the examples I'm using, we're in the banking domain, so we're going to mimic a lot of stock exchanges where trades are happening, and for every trade there's basically a price going up and down, and we publish some data to Kafka. It's not really about the data today, it's just to generate some data and see how things are flowing. So we will store that in a topic that's called stock quotes. It's basically a little bit of lingo here, but that's fine. You probably know that a Kafka topic has multiple partitions to share the data, and also to scale the consumers. More about that later. We will produce some data to Kafka, and they will end up in a partition. So basically, you can specify a key, right? And if a key is provided, that data, the payload, will always end up in the same partition. So you have ordering guaranteed in that partition. The responsibilities of the producer are, of course, sending the data and serializing that, and you both need a key and a value serializer. to get the data onto Kafka. This is, of course, really in a nutshell. The numbers you see are not the keys, but they are basically the offsets in the partition. Okay, then we can have consumers, of course. They will basically pull the data, subscribe to a topic, or even more topics, and then basically deserialize the data back for both the key and the value. And of course, it sends some heartbeats to the broker to say basically I'm still alive. And of course, you can scale the consumers, and they can work in the consumer group together to consume the data from different partitions. If you just have one consumer, it will basically consume from all the 3 partitions. And just to be sure, right, the broker itself is not responsible for any type checking, schema validation, or other constraints. In the end, the only thing we are doing is just sending bytes to Kafka by serializing and deserializing. In ING, we quite heavily use the Confluent schema registry, and we ask teams to look into this, of course, and define a schema first. It's basically the contract between the consumer and the producer, and can also be used, of course, with Kafka streams. And using Afro, basically we create an Afro schema first, generate some Java code out of it, and the schemas will be stored in the schema registry, so the producer doesn't have to send the schema along with the data. And it also is responsible for some compatibility checks, but that goes a little bit beyond the scope of this presentation. So basically the Confluent schema registry is responsible for schema validation and helps you to evolve your events and data later on. So that's it in a nutshell. And of course, you need to have a pair of serializers and deserializers. In the example, I also have a Kafka Streams application, but there was just not enough space to put it here on the screen. But Kafka Streams is basically a lightweight Java library that runs inside your application, so you don't need a separate cluster for that, and you can do stream processing and real-time stream processing with Kafka Streams. We will see that in a bit in the demo. So yeah, that was basically Kafka in a nutshell. Let's go a little bit into the Spring Kafka essentials, right? So you have Kafka here on the bottom. You still need the Kafka clients. In this case, we're using, of course, the Java clients to communicate with Kafka. So there's a consumer API, a producer API, and a Kafka Streams API. On top of that, you basically get Spring Kafka that provides you with all kinds of classes to do error handling, to if exceptions happen, for example, to recover those records by putting them on that laptop topic. We will see this in action in one of the scenarios. And then basically on top of that, you basically use your own code. Spring Kafka provides you with a Kafka template, like you have many other templates, like the GDBC template, Redis template, whatnot. So you can basically quickly produce messages to a Kafka topic. And one of the simple annotations is to use a Kafka listener annotation that you put on a method, and Spring Kafka will auto-wire all the producer and consumer factories and make sure that you have a really nice, concise piece of code that consumes messages from Kafka. Next to that, you have Spring Kafka test. We'll look at that a little bit later when we go into the testing part, where you can basically spin up an in-memory embedded Kafka. There are some pros and cons, but more about that later. And of course, some annotations for Kafka Streams as well. Let's take a really quick look at one of the producers that is running, basically on my machine. It's just a Spring component. We auto-wire the Kafka template, and we use the template to send, in this case, to the stock quote topic. For this example, I'm using the symbol. The symbol is basically a unique identifier for a stock. So it will always end up on the same partition. And we basically send the payload, and that's a stock. That's a price, a symbol, and some other data that we basically send to Kafka. And that's all you basically need if you're using Spring Boot to to produce data to Kafka. If you're on the consumer side, you can use the Kafka listener, specify the topic or topics, and then you get a stock quote in. You also have access, of course, to the API of Kafka, so you can also get a consumer record here. You don't have to do this, but this is quite convenient to get the stock quote object right away. And there are some annotations, for example, to get some Kafka headers that you can also use. And in this example, we don't really do something useful, but it's just to show how a consumer is built. I hope it's readable in the back. But you can also use Kafka streams. And in this case, we're consuming from the stock quote topic, and we make a decision if the stock has been traded on the NASDAQ. Then we basically branch it off to another topic. If it's traded on the Amsterdam Stock Exchange, we send it to another topic. So this is a really simple example of Spring Kafka, and it has a nice abstraction with the Kafka Streams brancher. That's basically another abstraction from Spring Kafka. And we're actually going to test this as well. Of course, you need a little bit of configuration, and here you see back the key and the value serializers or deserializers if you're on the consumer side. And in this case, we're also using the schema registry, so we have to provide the URL to the schema registry. Okay, so now we basically have our first producers, consumers. We have a simple Kafka Streams application, and we would like to go into production, right? What can go wrong? I wrote quite a lot of Kafka applications myself, and I stepped into a lot of traps myself, learned lessons the hard way, and today is basically about sharing some tips and tricks with you that you can apply hopefully in your own project and share with your fellow developers. So this is basically after the honeymoon phase is over. Don't tell my wife I use this picture, because she will she will kill me. So let's get started. I'm running a single Kafka cluster on my local machine with Zookeeper, of course, a schema registry, and this really helps me to get a lot of speed in my development. We still see a lot of teams that are using test environments. That's fine, right? But they're using this in their own development cycle. So some other colleague is producing messages, the other colleague is getting those messages. So the first tip is basically make sure you have a really solid local development setup. In this setup, there is even with some monitoring. So if you would like to get some inspiration out of that, you can just use it. I will share the link to the Git repo at the end of the talk. You can use some CLI tools, and in this talk we are also going to use some UI tools like Kafka UI, Conductor, or Confluent Control Center, which is licensed, by the way, but you can still use it if you have access to that. But this really helps to focus and to get feedback fast. Okay. Let's go into the first scenario. I will explain a little bit, and then we're going to run the demo, we're going to crash it, we're going to fix it. But let's first go into a little bit of theory. What is actually a poison pill? It's a message or a Kafka record that will always fail when consumed. You can try it 1 time or 1,000 times. With that same configuration, you will not recover from that poison pill. And they can come in different forms. It can be a corrupted record. I never actually encountered this myself, but most of the time you're hitting a deserialization failure. So let's take a quick look to our diagram again. So it's all running, producer, consumer, streams application is fine. And in this case, we are going to use a console consumer to send some data to the topic. And this console producer is not using Afro, so it's basically bypassing the schema registry, it's bypassing the compatibility checks, but it's still able to produce the data to Kafka. And then our consumer is basically having a hard time. Kafka Streams is a little bit more forgiving. It will basically stop if it hits a serialization exception. You can configure it to continue, but just to to show it here in the demo on just plain consumers you having a hard time, and we're going to show that now. So yeah, this is the consumer part. The consumer fails to deserialize. So let's say an Apple stock comes in, a price for an ING stock comes in, and then we hit the poison pill. Then basically the consequence is that you block consuming from that partition of the topic. Even if there are new stock quotes coming in, they will not be processed by that consumer thread. And if your application cannot swallow that poison pill, it will basically log an error message and will try again, and again, and again, and again, and again, and again, and really fast, because Kafka is super fast. And it will basically, if you don't have monitoring on top of this, your whole disk can be full in a couple of seconds, minutes, and yeah, basically every consumer that is not protected against this, will reach this point. So the impact can be quite high. I encountered this myself a couple of times in production, and it's not nice. Maybe you ship off this log to something like Elasticsearch, right? And that is also blown up. It's not nice to be there. So Spring Kafka basically helps to protect you against that. Just a couple of things we see that teams are doing. Some people wait until the retention period is over, right? Kafka stores the data for 7 days. Yeah, that's not really nice, right? 7 days waiting. Nah, that's a no-go. You can change the consumer group and then start from the last message produced to the topic. But yeah, then all the other messages you're losing, right? That's also probably not the thing you want to do. You can maybe manually or programmatically update the offset, so you basically go beyond that poison pill. But what if there's another poison pill waiting for you somewhere down the line? Can be quite tricky as well. But Spring Kafka got you covered, and you can basically configure the error handler deserializer. Okay, I think I showed enough slides, so let's go into some real code and get our hands dirty. Let's see. I already started the setup here. Let's see if everything is running. Yeah, so I have a single node Kafka cluster running here. Let's see if I already started the producer. So let's start the producer here. And it will start generating a lot of those stock quotes and just producing them to Kafka. It's just to get some data in and to show you the flow. Like I mentioned, Kafka streams will basically stop. It will not stop your application, but it stop the streams thread. But let's focus a bit on the Kafka consumer. So by now the producer is producing some stock ticks. Hope it's readable in the back. And the consumer is just consuming the data. So it's all fine. Let's take a quick look here in my browser. I have Kafka UI. It's just a really nice UI to see what topics are there. If you're connected to the schema registry, you can see schemas, and we're all good. Messages are flowing in. You can even see some kind of live view. So basically, this is all fine. Really helps me to see what's going on. Now it's time to produce a poison pill. So I'm going to use the console consumer. That's by default, it comes with the Kafka distribution and also in Docker. So I can just quickly go into the Docker container and going to use that. Yeah, let's unset the JMX port for the monitoring. Okay. So I copy this command here. Let's make it a little bit bigger. So I'm basically starting a console producer, and that will connect to the broker and will publish some data. And we're publishing it to this topic, and it's basically now waiting for my input. This console producer is not using Afro, So it will use a different serializer to serialize the data. And look what I found here. I have a nice pill. So let's try to break some stuff. Let's hope the demo gods are with me today. So yeah, now we basically produce this pill to the topic. And let's see, I feel my machine is already getting a bit slow. So you see it hits a deserialization exception, right? It consumed the data from that partition. It cannot handle it. It will try again, and again. Yeah, so my machine is already getting a bit slow, so let's kill it. The consumer cannot commit its offset to Kafka, right, for that partition. So if we start again, we will basically go into the same loop again. Why can this not be handled? Because the exception handles in before the poll of Kafka consumer returns, and there's basically no way to intervene. So Spring Kafka came up with a really nice way to handle this. So let's take a quick look. We're going into the configuration. Here we see our key and value deserializers, and we're going to replace them by the Spring Kafka error handling deserializer. So it's basically using those deserializers, and then we are basically delegating to the string serializer for the key and the Kafka Avro deserializer for the payload. And if an exception happens here in one of those deserializers, then Spring Kafka is able to do something with that exception. By default, it will just log it and continue. Maybe fine to at least protect. So let's try this. We now configured the consumer, and let's start the consumer again. Yeah. Okay. Spring Kafka, by the way, will consider those deserialization exceptions as fatal, right? It will not try again because it doesn't make sense. So the application is starting up again. It's going quite fast already. Yeah. So it will hit one time a deserialization exception and then logs it and will basically continue. So at least you could now survive this poison pill scenario. But you lost the message, right? In some cases it might be okay, but in other cases you might want to produce this to a dead letter topic so you can inspect this later on. So let's quickly configure this because it will help me with the other scenario as well. So I have a lot of examples, but let's focus on some configuration here. The Spring Auto configuration of Spring Kafka will basically give you a default error handler. Let's kick this one out for a sec and override the bean, or define my own bean for that. And I can basically plug in a dead letter publish recover. And that will help us to recover that message and publish it onto a dead letter topic. For the pill, it's maybe not that important, but for other messages that could not be deserialized, it might be useful. So next to handling the exception, we will basically start producing this to the topic. And you have to be aware that now your consumer application will become also a producer, right? Because it will produce that data to the dead letter topic. So let's try it again, start again. And we will publish one more poison pill. Let's give it a little bit of time to start. Okay, let's see. It's there. Yeah, let's. Of course, the pill doesn't matter. Any message produced, right, will cause this deserialization exception. And let's take a look at the log. So now we produce another poison pill to the topic. We protect our application against it, and we configure it to publish to a dead letter topic. So here you can see that it's actually producing that data to the dead letter topic. So let's take a quick look here at the topics. Yeah, here it is. So the dead letter topic is there, and let's take a look at the messages. Spring IO is there. Yeah. So of course now you have to manually inspect this because you don't know exactly what happened, but at least it gives you an idea what happened. Yeah, so this is basically one scenario to protect yourself against those poison pill deserialization exceptions. All right. So now we protected the application, we can still make a mistake in our own listener, right? So of course this is really obvious. If the stock quote symbol is kaboom, then we will throw a null pointer exception, but maybe you're calling a downstream service or getting another exception. Yeah, you may want to retry this. It depends, of course, if you can recover from this exception. And by default, Spring Kafka will retry for you. I think by default it will try 10 times. If it cannot handle that, then it will basically be evicted and will be logged into the log that you could not handle this message. But like we did now, we configured the dead letter recoverer, then it will automatically also publish this data to the topic. And we basically move on to the next one. It's good to remember that this is a blocking operation, right? It will 10 times try to do it. It will not consume other, in this case, stock quotes from that partition. The trap I stepped into was basically not thinking about this in the first place, and in some scenarios lost messages. And this is something you would definitely would like to try to avoid. And it's not acceptable in a lot of cases to do that. So what can we do? Depends on the situation, of course. We can either replace the default error handler or configure it. You can say, I would like to log it. I would like to maybe even stop consuming, if that makes sense. And you can, if you would like to do retries, you can also specify a retry back-off strategy. So, for example, to not overwhelm downstream consumers. So you can specify that as well. And like we did, we configured the record recoverer. So let's take a quick look here as well. All right. Yeah. So this is an example of a, let's remove this for a sec. This is a combination of both a dead letter recoverer and a backoff. So we can basically say, do on an interval of 0 milliseconds and try 5 times instead of 10 times, which is the default. You can also use a backoff. Now, let's see. There are many flavors to configure. It gives you a lot of freedom how you would like to handle this. So you can say an exponential backoff with an interval of 2 seconds with a multiplier of 1.5. So this is all there for you to explore, and you can basically say after 2 minutes of trying, retrying, then we will recover and publish to a dead letter topic. Yeah, let's keep it simple for now because we don't want to wait too much because I have some other stuff to show. Let's take this one and start the application again. So we'll try 5 times. We're going to send a kaboom stock quote to that topic and see what happens. Let's give it a little bit of time to restart. So of course the producer didn't stop, right? We just restarted the consumer. It will continue to consume the data. On the producer side, I exposed a small API just for this demo to do a HTTP call and basically send a stock to trigger that exception in the consumer. This is of course really obvious, but it's just for demo purposes. So I'm using the HTTP client of IntelliJ to send this to, in the end, to Kafka. Let's see, because it's quite fast. Here. Yeah. So the kaboom tick came in, or the quote came in. Was tried a couple of times. It could not handle this one because we always throw this exception, and then it will be published to that letter topic as well. So we will see it here. The record is recovered. In this case, it's next to the poison pill we also recovered from. At least you can take a look what's happening. Be aware that maybe in some cases some records will come through, some other records will not come through. So in this case you have to think about, can I send this message again, for example, after a bug fix, because it might override data in downstream. If you're storing some data, for example, in a database or so, then it can have some really nasty side effects. So you really have to think about this. So in some cases you might even want to stop consuming. It really depends on the use case, but Spring Kafka got you covered to basically do this. You can even configure for different exceptions, different strategies, how you would like to deal with them. So there is a lot of flexibility in there. So that's probably quite cool. So this was about exception handling. Then about testing. When I started with Kafka, I was quite heavy on basically integration tests. Spring Kafka provides you an annotation that's the embedded Kafka to basically start up a single node Kafka instance. And you have access to the embedded broker to basically use that. But at some point, you have a producer in one service, you have a consumer in another service, you have a streams application. In the beginning, it was quite nice also to learn how Spring Kafka works, but at some point, I was basically writing full-blown end-to-end tests and got a bit shaky, especially when you're using Afro as well, because the embedded Kafka doesn't have support for Afro. You can all fix this, of course, but at some point, what are you actually testing? Are you testing Kafka or Spring Kafka, or are you actually testing your code? Of course, there are situations where we would like to do it, but my advice is be a bit careful with that, especially when you are building Kafka Streams applications, because there are better ways to do it. For me, it also feels like the embedded Kafka is a little bit testing against an H2 database, right? So you're not really using the exact same, for example, Kafka Confluent version. So if you would like to do that, you can take a look at test containers. There is one for Kafka, and the former developer advocate of Confluent, Victor Gamov, also started a project to basically start a schema registry next to a Kafka broker in your test. So that's another option if you don't want to use embedded Kafka from Spring Kafka. But nowadays, when I'm writing Kafka Streams applications, I would try to focus more on unit tests. And I'm using the topology test driver. That's, by the way, not from Spring Kafka, but it's just from the Kafka Streams test library. And I'm going to show this in action, how that works. Let's go to the code. I just included this slide. If you, maybe take a look later on. But I think it makes more sense to show it in IntelliJ. So let's go to our Streams application here. I can start this up as well while we're waiting. It is of course a super simple application. Like I mentioned, we take a look at the exchange where the stock was traded, and then basically send it to different topics depending on the stock exchange. And if it's not matching one of those, it will basically be published to some kind of bucket that contains all the other exchanges. So how to test this, right? I can stand up in test containers with embedded Kafka. I can start producing something and then basically wait with some thread.sleep or whatever until this message is processed, consumed, and then at some point consume it back. But it's quite unhandy. So I would like to use the test topology driver, where you can basically, let's go quickly over it. Let's make it a little bit bigger. It has support to basically mock out the schema registry, so it will register a mock schema registry client for you. You basically define your input topic, where the producer is just producing stock quotes to. You can define some output topics, in this case one for the New York Stock Exchange, the Nasdaq, the Amsterdam Stock Exchange, and the other one. Of course, Spring Kafka is managing our Kafka streams, but we can still get access to the K-stream, build a topology. Of course, we have to set a little bit of serializers and deserializers here, and to mock out the schema registry. So this is a little bit of setup to do, but in the end, if we focus on the test, we basically, on the input topic, produce a stock quote. Then we can verify that it is not empty, that it has one stock quote in the queue, and if we read that value, it is exactly the same stock quote that we published. And we can check that the other output topics are empty. This is of course a super simple example, but it really shows that you don't have to stand up a whole runtime for Kafka to test your Kafka Streams applications. Let's see how much time we have left. A little bit more than 10 minutes. Let's see if we can cover this as well. So if you're in production, then it's also, of course, super important to monitor, right? So to come back to the 3 pillars of observability, logging is already in place, of course, by Spring Kafka, by Spring Boot. Since Spring Boot 2.0, Micrometer is the default metrics, a library that's basically SLF4j for metrics. And if you're using that with Prometheus and just add the Micrometer Prometheus metrics, it will start exposing the metrics for both consumers, for producers, and also Kafka streams out of the box. So I'm actually running this here on my machine. If you're using Spring Cloud Sleuth, and in this case with Zipkin, it will basically also add distributed tracing out of the box without a lot of hassle for you. And I'm going to show that as well. So you can see basically the messages are traveling, they are produced, they will be consumed by a consumer or by a streams application, and you can basically follow along and correlate that to the spans and the traces in your logging. Is really, really nice. So here again, Spring Kafka shines as well, and this is an example of the consumer metrics that you get out of the box with Micrometer. Let's take a quick look. I think I already started the Kafka Streams application, so let's first take a look at Zipkin. I really like the view as well. So if we go to the dependencies, let's make it a little bit. So we can basically see here the Kafka broker in the middle. We have our consumer application, we have our producer application, and our streams application. So the producer is of course producing, the consumer is consuming, and in this case the streams application is consuming from the topic, and depending on the stock exchange also sending data back to other topics. So this is a high-level overview, and of course you can go into a lot of details where you can basically show all the steps. And this is of course to basically, if you have some latency issues, to figure out where stuff takes time. So in this case, the producer was using this class to produce the data. It was sent to Kafka using this Kafka key for the record. It was sent to this topic, to this broker, and you can basically follow along that it was consumed by a consumer and also by a Kafka Streams application that in the end apparently sent something back to this Amsterdam Stock Exchange topic. So yeah, this is really nice to do some distributed tracing on your producers, consumers, and Kafka Streams applications. Yeah, let's take a quick look at Micrometer as well. Like I showed, the producer is running on port 8080, and here we see the producer metrics. Same goes for consumer. You can of course turn this off, right? If you don't want to have all the metrics or just a subset or whatever, you can tune this, of course. And this is the Kafka. No, sorry. Yeah, this is the streams. So it has more, right? This consumer, producer, and streams. And if you're using Micrometer with the Prometheus library, Micrometer Prometheus, then it will basically export those metrics in the way that Prometheus can scrape it. In this case, I'm scraping the consumer and producer with Prometheus and have some dashboards. It's all in the code base, so you can play around with this, start it up, see what's happening, and let's take a look at the dashboard. Yeah. So this is an example where we basically get out of the box some metrics with some nice dashboards. Yeah, that's it in terms of metrics. Yeah, just the things I showed. Distributed tracing. Yeah, so let's get back to some lessons learned. For me, it always makes sense to invest time in your local development setup to get fast feedback loops. Spring Kafka is super powerful, abstracts a lot of boilerplate code away, but it also helps to understand the core Kafka API if you have to dig into some issues. For the consumer, expect the unexpected. Make sure you can handle deserialization exceptions. Do proper exception handling. You can even validate incoming data. I think I didn't show that today. For the producer, yeah, don't change your serializers. Be sure you're backward compatible and you don't break your downstream consumers. So you can leverage the Confluent Schema Registry. Yeah, always think about who can produce to my topic, right? In ING, this is quite nicely handled. Who can consume my data? You can even get into a deserialization exception if you, for example, configure a deserializer wrong on the consumer side. It doesn't necessarily have to be the producer. That's what I showed today in the demo, but it can also be your own fault in terms of configuration. Yeah, monitor your topics, your consumer groups, and of course your applications. Micrometer and Spring Cloud Sleuth will give you the distributed tracing and the metrics. Yeah, and don't step into the same trap I did by creating a lot of integration tests. Yeah, that was basically my talk. I think